Hello everyone and welcome back to my channel. First, I want to apologize because I didn't have time to upload any video in the past few months. I had to finalize many of the things that I was working on, including some manuscript, and also I had to work on my dissertation. And also I have a full-time job right now beside my PhD candidacy. So I didn't really have time to spend on these videos. But thank you for your emails and encouraging comments that you shared with me. I really liked them and I tried to answer some of them as best as I could. And I noticed that in many of the emails that you sent me and also some of the comments, you were interested to find out how you can extract information from the ODB file. So today I'm going to go over that with you with the example that we've covered in the previous tutorial. We want to use the simple compression test specimen and learn how to extract information from the ODB file using ABAQUS scripting. So I'm going to go over these details with you. First, I want to import previously created script, the Python file that we worked in the previous tutorial, and save it as a CAE file. Then I'm going to run the job and extract some information from the ODB that I'm going to get out of that compression test specimen. The information that I'm interested in getting for the purpose of this tutorial is to save the contour image file of the Mises stress from the cut specimen and also redo it through the script for the PEEQ stress, plastic equivalent strain. And I want to do export stress strain data from the PEEQ versus Mises from one element and redo it from the list of elements that I'm going to choose again through the script. The next thing is going to be export stress strain curve information, the data to a text file so that I can ask MATLAB to read that text file and export those information or post-process those information if I want to, again from a list of elements. And the last thing is going to be save an animation of the stress Mises and redo it for either the PEQ or different kind of stresses that I'm interested in. So that's the content of this tutorial. The first thing I want to do is to take a look at the script that we've worked in the previous tutorial. You can see that the script that you can find from my shared Dropbox folder is like this. The first thing that I did was to change the mesh size from 0.25 to 0.5 to be able to easily and quicker finish the simulation, because in this simulation specifically I didn't use any symmetrical conditions, so it may take a little bit time. That's why I increased the mesh size, and I didn't change anything else. I saved the file into C temp folder just for easier access, but you can save it of course anywhere you want. You can import this text Python file from here. Go to File, Run Script, and then Simple Compression Test, which is this one, and hit OK. It will do everything that we did in the previous session. It's going to create different parts that you can see from here. Specimen is like this, surface, property. You can see that we used aluminum, but to be honest, I forgot what was my unit system. So I'm going to just use this table that I have as my background. Go here to edit. Density, you can see that the density of aluminum was put as 2.7 times 10 power minus 9. And in that way, I can see that, for example, the density of steel was in this magnitude when the unit system was ton, millimeter, second, Newton, megapascal, and etc. So, for example, this elastic modulus, the unit of it is going to be in megapascal. As you can see here, these are almost 70 gigapascal. The unit matches and everything. So if we go to the assembly, you'll see the specimen and also those two surfaces. Here you can see them better. If you go to the step, you'll see that we asked ABAQUS to export some information for us, different kind of stresses. But the one thing that I want to point out is that we asked for 50 interval, every space-time intervals, 50 intervals total, and total time for the duration was 1 second. So this is an important information for us, because if we want to save an animation, this will be the total frame number for this simulation, because we just have one single output request, and that has 50 intervals. For the interaction, I believe we had a kind of general contact interaction. The load was based on the displacement as far as I can remember, because the displacement value was 5 here, put as 5, and based on these units that I just talked about, that's going to be 5 millimeter, right? So the bottom is fixed, the top displacement is going to be 5 going down, and we had a really simple amplitude, I think 0.011. And now with the mesh size of 0.5, the specimen and the surface looks like this. And we can check the job, see if the job is there, but it's not submitted yet. The reason that it's not submitted yet is because I've commented the last line here. If this line was not commented, probably we could the job was run like immediately after we run this script. But since that line is commented, the job is just created, and then the whole thing is saved. Now I want to save this as like save. I can say compression example as a CAE file. Once the compression example is saved, I can submit the job, wait for it to be finished, and then we will go through the ABAQUS scripting for the output results. Welcome back. So now the job is done, and I have this ODB file. I don't need any of the other files that is created at the time that the job was running. I just need this ODB file right now. And there is another file that you can see that was created when ABAQUS was started, and because this is a fresh start of ABAQUS, I don't have it right now. I mean, mine might be a little bit different with yours, but it's called ABAQUS RPY file. Do you remember the time that we were working on the scripting for the model? We used the JNL file, the journal file, in order to get information from the from the ODB file, or to script the outcome from ABAQUS, we should use this RPY file. And the concept is really similar to what we've covered in the previous session. So now I want to open this RPY file. You'll see that the RPY file starts with some commands like this, and these are the things that we will need at the end. So I'm going to just copy these into my own ABAQUS script for the output. And you can change these information. These are related to the size that ABAQUS needs to start when it's starting. So I'm going to just change this to 340, I think. And you can change these heights and everything. So I'm going to change these for now to these numbers. And whatever we are going to do with the model is going to affect this RPY file. So I'm going to do it, for example, here. If I open my ODB file, you'll see that some lines is going to be added here. So here it's saying that the ODB file is this file, the name of the file is given, and then the viewport is going to set to that ODB file. So this is another line that I'm interested in order to start everything fresh the next time that I'm starting ABAQUS and also running this script. The next thing I want to do is to see the specimen, how it's deformed, and probably have a cut as well, because I'm interested in seeing this inside of this specimen and see how stresses is going to change in these shear band locations. So if I put my view angle to be this one, I can see the specimen pretty well. This is not the best simulation because the mesh is really coarse and everything, but it's fulfilled the purpose anyway. And also I need to remove all these lines, the element lines, so I should just use feature edge. Okay, So this might be a good thing to use for your publication or whatever. So I'm going to take a picture from this thing. First, go back to the RPY file and see what we are seeing here. The first few lines, this one shows you that we are seeing the deformed specimen. This is what we need, for example, if we want to just use the redo the exact same thing. We want to see the deformed specimen. Then these lines are related to the fact that we just change the angle of this specimen. You don't need all those. The only one that I'm interested in is to see the cut slice of this specimen, which is this one. This is Python language, so you need to be careful with the indentation, otherwise you'll get some errors. And this one changed the viewpoint to the right point, and this one was removing the edges of those elements. So I'm interested in these lines as well. Just let's add some extra lines here. So this part is going to be to save S-meses, stress meses image. The first one is going to change the specimen shape to its deformed position, cut it, showed at the right angle and the right viewpoint, and also remove the details, the element details. Now I want to save this file. If I go to save, print, file, and it's better to just use TIFF because of its quality. And I believe I didn't change anything here, but I'm going to save it as S-meses, like image, something like this. And I don't want any decorations. Apply. And you'll see that I have this information in my RPY file. This information tells ABAQUS to save the image as S-meses, and the format is TIFF, and I didn't change anything else. So if I change actually what I'm seeing here from the stress meses to PEEQ, I can see that in my RPY file I'm going to have another line, which is this line. This is the primary variable to be shown in the display mode, which is these few points means that I want to have the PEEQ shown in the display, and that's what I need if I want to save the PEEQ image. So let's go to save PEEQ image, and because I don't want to change any of these, I can just set these as these values. I don't want to change any of these parts for the PEEQ, but I just want to save another image from this thing that you're seeing over here. So here I'm going to copy and paste those lines and then save it as image PEEQ, right? And also it's a good practice to just check to make sure that the image is saved or not. So here you can see that the image is saved almost perfectly. So if I run these few lines, I'm going to have another image saved for the equivalent plastic strain. But already I'm sure that ABAQUS is going to give me an error, and the reason is that it doesn't understand any of these unless I rewrite these few lines. Let's try. You see, it's giving us an error saying that the integration point is not defined. In order to solve that, you just need to copy these few lines, the one that is importing some library and information to ABAQUS. When you're running it in the script mode, the first time that you add these lines, it's going to give you no error. It's going to work. But when I'm trying to run the script without importing these things, it's going to give me an error. So I'm going to copy these lines, and you'll see by entering I didn't receive any error, and there is going to be an image of the equivalent plastic strain in this folder. So that's being done. The next thing, if I want, for example, to change something and take another picture, I can do that definitely by another cut or something, but I don't want any other kind of information from this experiment right now. So the next thing, so the contour of Mises stress cut, redo it for the PEQ is done. Now I want to export stress strain information from one element and redo it for a list of elements. Let's see how we can do that. Again, I'm going to adjust my viewpoint to this one, and I'm going to bring back those element edges because I want to select the elements easily. And you can do different kind of things to find out what element you're exactly seeing right now, what's the name of the element or what's the number of this element. But one of the things that you can do, I believe, is to use this probe value, and here you'll see the number of elements. So for example, if I want to get an information from this specific element, the number of it is going to be 7,560. This one is going to be, I'm not going to even concern about the number of them because I'm going to have the list over here. So if I want to have the information extracted for all of these, I can do it in Python pretty easily. But before getting all these element numbers, let's select different ones so that we have different kind of ranges of numbers. I'm going to select one from this surface that is really close to the rigid surface. And I'm going to select another one, for example, here. So let's write down these numbers. You may be able to save this information even somewhere. Let's save it here and see. So if I believe it was RPT file. Okay, there you go. So we have the list of these elements, which is this list that I'm interested in. And I want to redo something for all these. So how can I remove all these numbers? So I'm going to select this. And by the way, this text editor that I'm using, because many of you asked, it's called Sublime. And I believe it's by far the best text editor you can use. So I'm going to select these numbers. Again, find and replace. I'm going to just use one space, replace all, and then I will have the list of elements that I was interested in. Okay, so here is my list of elements that I want to do something on. So I want to get the PEQ Mises stress from a list of elements. Okay, there you go. And EL list is going to be, oh, there you go, is going to be this thing. Python doesn't understand this probably, so I need to separate them by comma. And maybe that's too much. Let's do it on this one. It's not going to take any time, but then we'll need to find the files, and we'll have lots of files. So this is just the list of elements that I want to export some information from. Forget about these lines. Now I want to extract information only for one of these elements, which was this one close to the center, number 7,560. So let's go here, and I'm going to get the history out or field output. And I'm going to get PEQ and also Mises stress from centroid, pick elements. The element that I'm interested in, I believe, is this one. Save this information, dismiss, and you'll see that this information, this is element 4424. And you'll see that you can export the XY data either by copying and paste this information. And you'll see that the total number is 51, 00 is the beginning, and 50 field output request that was done for the whole time that the simulation was set to be run. So the step time was 1 second, and that's all the numbers that you have. You can copy and paste these onto your Excel or whatever, but it will take really long time to go over these. But I'm going to show you how to export this as a text file and then import them in MATLAB in another tutorial. But one thing I want to do right now is to see the specimen, is to see the flow curve exactly at that location and at that element. So how can I do that? I can go to operate x, y data, then go here, combine x and y, select this one, and then let's save as, that's the name, and then I want to select it. And this is the stress strain data for that element. So once I have this, I can save it again, just for the purpose of this tutorial anyway. I'm going to say that I'm going to save PEEQ Mises, and the number of element was 4424. Okay. And on my temp folder, I should have this thing, right? So I want to save the same graph, same plot for the list that I've created before in a loop. How can I do that? So let's go back to the RPY file and see what happened when we export this plot. The first line is this that I'm going to choose. I'm going to copy and paste all these into my Python file that I'm interested in making. So I'm going to copy those lines. But take a look at this file, the first line. In the first line, we are just showing an active ODB to ABAQUS. We already done that in this line, so I'm going to just remove this completely and change the ODB to 01 because it's already there. And the other thing that I want to point out is that if you run this code, it's going to save the same figure for this specific element. But how can we change the name of these elements? You can see that in the element pick specimen 1, we have this specific number that is showing the ABAQUS what element we are choosing, but we cannot really easily change that. So I need to change this to something else. How can I change it? I need to change it to this thing. Elements, labels. Specimen 1 is just fine. Remove this line. And then here, instead of this, I'm going to show ABAQUS another thing. I'm going to say, for example, let's just try it first, and then we will see. 7560. I believe that one of these parentheses should be removed as well. But let's try. Name error 01 is not defined. Okay, sure, because you don't know what 01 is. So I'm going to recopy this thing for you. Now you know what 01 is. And then I'm going to get this information from you. And okay, there you go. It worked. So what it did was to create these two data sets from that specific element that I was interested in. So how can I redo it in a loop? I can say, for example, for EL name elements, changing for EL in EL list, do this thing for me. And I believe in Python, because it's been a while that I didn't use this thing, I need to go back to my memories and find out how should I do it. But I believe it's this. For EL, I prefer to use num. For element number in element list, do this. And for this one, instead of this, I'm going to say string of EL number. And hopefully it will do the same thing for me. Here it probably is not going to understand, it's not going to understand any of these, or it's going to just copy the information for element 7000 something to element 4000 something. So I need to carefully replace all these things to the things that I'm interested in. So here I need to change it to this, and because it's a name, you need to change it like this. So here again, this number should be changed to this, and this one. Again, -1 should be changed to dash this thing, And we have a problem somewhere. Okay, there you go. I believe it should work once we apply all these changes. Let's see. Okay. Is there anything else we need to change? I don't think so. So copy, and in order to avoid any kind of confusion, let's delete all of these, because if you don't, you're going to ABAQUS is going to say that I have this information from somewhere else. Again, I cannot copy those into the new ones. So EL list is not defined. Sure, yeah, I didn't tell you what EL list is. First, okay, there you go. You see that the elements, the information from all these elements, from 241 to 7,000 something, these 1, 2, 3, 4, 5, 6 elements, yeah, matches this number as well, is exported, and the XY data is recorded on all of these. It's combined, and I believe if I go back to my folder, all those information is going to be also here. So for let's do it by name, PEEQ misses from this one up to here. So in order to make sure that everything is updated and they're not the same figure, basically, you can check with different things. This is for elements 7,560. The information is also here. The yield stress is around 100. The max number is more than 450. And for this specific element that was way below that, the yield stress is almost the same thing, but the max number is below 300, and that's reasonable. So we were able to accomplish that part at least. The next thing I want to do, let's save this thing. What can I give a name to it? For example, I can say ABAQUS output. I cannot see my keyword. Output example .py, which is a Python file. That's my output file that I want to, script that I want to run later on.